Welcome. My name is Uwe Kaiser. I'm from the Fraunhofer Institute Focus in Berlin. And within the GEN6 project, I'm part of the national project. And on the other side, the project member voted that I have the job of the technical manager within GEN6, and I have to keep all these 19 partners together. So, because many of my colleagues out of the projects are here to give presentation about the national projects, the cross-border stuff and all these things, I have done a little bit larger way to come to the GEN6 projects and to the content. And I have been looking a little bit through the web what have been done on IPv6 for governments in the past with a special look on the Commission. And if you look 10 years ago, there have already been technical projects what can be done with IPv6, but nothing with governments. If you look at the websites today, you see that there are again IPv6 projects like the IPv6 Observatory, the Internet of Things on IPv6, a very interesting part, and projects like 6Deploy, where the deployment process is done and done by trainings throughout Europe to get governments, to get institutions on IPv6. IPv6, I think there has nothing to be said a lot. The addresses are gone away, right, is empty. On the other side, the providers are switching silently to IPv6. In Germany, I think the telecom is doing there where you have an IP network access and your access equipment to the internet is IP. They offer you IPv6 in certain areas at the moment. And if your DSL box, the Fritz box at home is doing IPv6, somehow IPv4 is going away silently, and most of the users will never recognize this. And the IPv6 world days draw naturally attention to IPv6. You have a slow curve going from the left, and it's going up, and some imagine or some wish that this curve, if you mirror it the right way, is much interesting for the IPv6 community. But if you look on the government sector, there is currently no big activity to deploy IPv6. And we had a national project on IPv6 for doing a roadmap, transition support and so on in Germany. And if you talk to the guys in the network centers and say, why are you not going to provide IPv6? They are asking, what's better on IPv6? What can I do more with IPv6? Does it solve all my problems? And then you have to admit that it not necessarily solves every problem you have in a data center or in a network operation center. But then you talk about video conferencing and all this stuff. You have, what's it called? You have multicast inside the protocol. You don't have to set it up explicitly. And then, who is doing video conference in governments, in ministries, on the local level? No problem for me, no argument. On the other side, introduction of IPv6 in governments has to be planned and organized. They are doing it not from themselves. They need resources, and if you look into the IT equipment of governments, local governments, they have been reduced to a very low level. So there are no resources available to do planning of a future IPv6 introduction or other service. It takes time, necessarily. And driving the data center is still the same work as before. And if you talk about dual stack, you have to admit that it's double work, because you have firewalls and all the other parts where you have to maintain the same rules in some way. And at the end, these data centers on the government level have to set, if there is no order from the top, you have to introduce IPv6, they have to set themselves a target. And that's a difficult task sometimes. So if you look on these people who are driving the network and they have a running network, it's hard to convince them, why should I move to IPv6 if everything is running? On the other side, even in the government area, you have those people running services on top of the network. And if your service is not reachable anymore because the provider in China only had IPv6 addresses, your device, iPad, smartphone, no problem, IPv6, that's fine, but you can't connect to the services at home, then it's interesting for the government and for every other part to deploy IPv6. There are some other reasons and factors driving this, but there my colleague will talk about this somehow. If you look in the areas from government where you have national roadmaps, you can look on the net, you find the government roadmap from the US, which is maintained over the whole period of time, but you also find roadmaps in India, Malaysia, Uganda, which have set up 5 years before. And if you look nowadays on these roadmaps, you don't see any updates, you don't have any reports on the deployment of IPv6 in these networks. What happens in Europe? This remark from December 2010 was a workshop which was done by the European Commission in Brussels, and you see a number of names here. And if you look in these countries, these are the same persons driving IPv6 in those countries. There are still IPv6 activities in some other countries, but as Fabrice said just about France, in some countries you don't find any information what's going on IPv6, what's the state of deployment, and somehow you get the impression that they are hiding somewhere and waiting what is delivered, what is offered to them to go the way to IPv6. The simplest way to draw attention and to get people together to work on this topic is somehow to catch them with a little bit like you catch a mouse. And this was a way, and I'm very thankful to Jack and some other people who organized or who had the idea to set up GEN6. And GEN6 is not a normal project as every research project where you have a target, you do your research, and at the end you have a result. The idea was to fund national projects already doing IPv6 deployment in their country. And from these national projects, we have data centers on their way to IPv6, backbone infrastructures, which will be migrated or have a transition in this area, and on the other side, not the low-level part, but also government services, portals, and other stuff. Doing this on the national level is fine, but what helps national IPv6 if you can't prove that your connectivity to the other member states that cross-European services as established currently on IPv4 are available also in 6. And this was the reason because in this call, cross-border activities were one major part which has to be covered inside the project. So we have cross-border services on the government services side, which is a little bit difficult to achieve at the moment because currently we have no government with IPv6 services. And before we can run IPv6 services, we have to get the government network on IPv6. And we have in this project 2 partners in the area of emergency services for fire brigades, So on the Slovenian part and somewhere in Luxembourg, and the idea is that those national projects should provide or should prove that these services can be connected in different ways using IPv6 and on emergencies, yes. So the objective of the GEN6 project is that from this experience we have on the national projects on everyday services which are running at the end of the next year, or this year, next year, that we should derive best practices and showcases for all those waiting on directions how to proceed and how to deploy IPv6. And it's also about practical steps. You can't say you have to do it the whole way, and there are also different scenarios. Dual stack is one way, it's a proven way, because a lot of people have gone this way to introduce IPv6, but there might be other solutions necessary for certain scenarios to get to IPv6, and how to proceed in this way should be documented by GEN6. And every national project is in charge to document their own national project, the approach they have taken from addressing to other things. So if you look, we have 1, 2, 3, 4, 5, 6, 7, 8 countries inside this project, and every partner has a special look and task inside the project. Our Czech colleagues are involved in dissemination and doing the technical, there's a switch, characters, okay, monitoring of this project, which started after the half of the year because we had a review and it was a recommendation that monitoring those governments will be a good idea. I show you some slides afterwards, I'm not quite sure. The German project is the transmission of a regional data center. The SITCOM is a data center provider for communities, cities, and local governments, and they are switching their complete infrastructure and access infrastructure to dual stack and so on. The talk of the Greeks on tomorrow is about their school network and the use of sensors inside this network to monitor energy consumption. My colleague on my left side with the University of Luxembourg are working on public safety and on migrating cloud infrastructures or one cloud infrastructure to IPv6. Current open source infrastructures are partially capable of IPv6, but it's seldom used and implemented completely over the whole cloud. My colleague Arjen from the Netherlands, TNO, is doing the monitoring, and we also had a partner in the project, the city of Alkmaar, which switched to the state of an observer. They are still enabling their government front and back offices to IPv6, and I hope they will provide some report at the end of the project how they succeed in this area. Turkey is moving their government portal services to IPv6. The whole government services are under one portal, and this portal and the whole infrastructure behind the portal is transitioned to 6. Spain is doing the transition of the core network. I will show some slides on this. And our Slovenian partner has an emergency response environment for the fire brigade as a national project, and they are also doing these services on 6. So now I will show some slides of these projects, but I will only do it very short because most of the colleagues are here and giving in detail presentations on their services. That's the architecture of the Spanish government backbone network. And to this network you have connected the ministries, you have connected autonomous communities, you have a management center, you have single sign-on facilities for services, companies are connected for certain services to this network, and this backbone network will be on 6. But as usual, and in government it's not unusual, not everybody is on the same level in such an environment. Some are far ahead and using IPv6, others are still on 4, and even if you have your backbone on 6, you have some islands where you have IP or IPv4, and you have to be sure, or you must be sure, that services which are done by more than one institution will still work even if one is on 4 and on 6. So some techniques are necessary to make this available, otherwise you will never get some institution or ministries going ahead to go to 4. This is a slide of the Greek school network, the overall structure. On the top you have the Greek research network, then you have some nodes inside the research network, and at the bottom level you have the schools, the sensors, and all this information is connected. But it's not every school on this network, and as you see on the right side, there is still the national carrier of Greek, where some schools are connected, and even for those schools on the public carrier, they are equipped with these sensors, these information systems, and giving back the information to the Greek network, where this information is collected. And every school is possible to see the energy consumption of everybody on this network. And therefore, with these sensors they have deployed low level, they want to try to get a little bit competition between schools about energy consumption and how to deal with energy in general. These are the slides from the Luxembourg pilot. A lot of governments or local area governments, whether public cloud or private cloud, using cloud technology. And the question, cloud technology addressing, you have virtual machines and all this stuff. Currently, sometimes you have IPv4 addresses. If you don't have them, you are using private addresses, then you have to NAT. If you give these services to the outside, then you have outside addresses, you have to NAT inside. And all these problems you can avoid if you use IPv6. You can give to every machine, to every instance, an IPv4 address and make it much easier to manage such a cloud service and distribute resources inside your government community. So what from the technical part, I think you use an open source cloud infrastructure, OpenStack, and they are trying to avoid the whole trouble they get from IPv4, for instance, the thread NAT stuff, and replace it by IPv6 and make this the service on their net. This slide shows the infrastructure of the data center of the German national pilot, and you see on the left side the back office infrastructure of Sitcom with application backbone, the Sitcom internal network. That's the core. They are just trying to make or set up on dual stack. Then they have the internet access. They are running for their customer their own network, which is based on MPLS. Also, this should also be IPv6 capable. And the way down to the right corner is the access to the German national government backbone. And over this backbone, you get access in Germany to the European S-Tester network. Tomorrow, Werner Schülting, who is the coordinator of the project, will give a talk how the transition of the German national backbone, which is the second bubble from the brown bubble from the bottom, the DOE backbone. And I think Antonio will also talk about the S-Tester cross-border stuff we are planning in Work Package 4, right? Right. Oh, today. In the afternoon. Okay. So, and this work is currently in progress, and it's on a good way, and it seems that we will have on the national project this dual stack on the core network ready in the end of the year. This is a slide from our Slovenian partner, and there is a point where I can't explain very much. The idea is in Slovenia that there is an emergency control center on the backplane, on the left side. They have a core network and they are supporting more or less every type of access and protocol for their emergency units like fire brigade cars and so on to connect to this network. So in case of a fire alarm, they go out somewhere, try to get access to one kind of network. This might be some wireless networks, this might be LTE, or there might be some other access point. Connect their car to this network and all the information systems of the car. There might be a video camera on it, there might be sensors attached to the fire brigade men to see where they are located during their work. And all this information is transferred to the backplane, and this is done and currently developed under IPv6. So this was a short overview of all these national projects we are running. And the last slide is just connecting the Slovenian part on the right side with the Luxembourg part on the left. And this is one of the cross-border pilots to get these two emergency and safety systems connected and make them communicate, exchange information in case of some event. I mentioned in the beginning the Czech Republic doing some monitoring. And from this monitoring, I will not explain all this data. And I've taken out the information from Germany. So I'm blaming just myself at the moment. If you look at German government institutions, and these are all ministries, then you can see how far web services are available on IPv6. There are some on the national countries or on the countries for a little bit outside of the normal list. That's Berlin and Bremen, the only two in Germany. So that's the actual state of IPv6 deployment or availability of services in the government area. And tomorrow, my colleague Jerry will give a presentation about the monitoring we have set up in Work Package 5, and then you can look how this looks like over the whole of Europe in the area only government. So what are the results of this project? We are collecting the information about network topologies and addressing types and schemes used in the different countries in the national projects and make them available as a separate deliverable. Every country uses their own approach to addressing plans. This depends somehow on the structure of the country. Somehow you have a centralized country, you have a centralized addressing plan. If you look at Germany, we have a federal government, we have 16 countries around, but we want to have them under one addressing scheme and plan so that government can identify within one block of addresses. How this works, Constanze Bürger will talk about tomorrow. But we are collecting this information and are making this available so that others can have a look and decide which approach is the best for them. Deployment strategies. Each country, each partner has a different deployment strategy to get their national project into operation. Another part is profiles for interoperability. I think most of you know the RIPE 554, it's a new number, document where they describe which capabilities IPv6 equipment should have that they can work together. There was a German national project which extends the work of RIPE a little bit more detail, but less than in the US government description of profiles. And this will be made available so that with these profiles and recommendations, it's mandatory and optional, you can be sure that your equipment will give you the basic capabilities to communicate with IPv6. There are some reports on the implementation from the projects, and at least we will generate every theory every quarter or every 2 months? What did we decide?
Every 3 months.
3 months.
Yeah, every quarter.
A survey on IPv6 for governments, and we started with 18 partners. We had a review last year, a very short, after half a year, and there was, the decision was taken that we extend the project by academic partners. And this, we had a meeting this morning, and also for universities, we will extend the monitoring part to have the governments and the universities outside this project and make these reports available to show who is ahead deploying IPv6. And that's the short overview I want to give about the project GEN6, which is a little bit different than normal research projects, but I think it's a valuable approach to make the results from different countries available for European countries still waiting or still having not decided how to implement and to deploy IPv6. So, if there are questions, I will be available in the coffee break or now.
I think we